Join me on a fascinating journey where I show you some of the techniques used in scale aeromodelling.
Hello again, modellers, and welcome back to the channel. We're in the workshop again. What I'm going to do this time is I'm going to go and start a new little project. As you'll know, the indoor RC Scale Nationals is in April at Wolverhampton University's Walsall Gym, and it's an event I've been supporting for some time. This year I'm not organising it, I'm just going to be taking part. So it's time to start thinking about a model for that event, and what I'm going to do is something that I've never done before for any model of any size, and I'm going to take a leaf out of a few other model designers as to how they go about producing a scale model. Ordinarily I would take a 3-view, or I'd create a 3-view of my own in CAD, and I use TurboCAD, which is a fairly cheap and cheerful well, it's actually a 3-dimensional CAD software, but I tend to use it in 2 dimensions only. Anyway, what I'm going to do is something that other modelers do quite frequently, and that is they simply enlarge a 3-view that they've found that they reckon is fairly accurate, compared to photos and what have you. They take a 3-view, they enlarge it to the scale of the model they want to build, and then they simply build on the 3-view. They don't really draw a plan, and they don't do any CAD work or anything like that. They simply build over the 3-view. And that's something I've never tried. So it means you've got to think on the go all the time, because you've not really thought through how you're going to build it by drawing a plan. Because the act of drawing the plan forces you to think about spar positions, rib positions, bulkheads, all sorts of stuff like this. Well, we're not going to have any of that. So what we're going to do is we're just going to take a 3-view, scale it to the size we want to use, and then build an airframe on that 3-view. And this is how some modelers actually build their larger RC models, exactly like this. Anyway, let's take a look at the 3-view and see what we've got. Here I have the 3-view that I've printed. It was A4 and I've printed it up to A3, and it's a 3-view that was drawn for the Blackburn 1912 monoplane, and this was drawn for Aeromodeler in 1951, so it's a fairly old drawing, and it's a little bit woolly, but it's still quite a good drawing. It's been drawn quite well. So what I'm going to do is I'm going to blow up each of these aspects to a 40-inch span, and then we'll see what we've got from there. So here they are, and all I've done is enlarge them in Illustrator and then printed them out on A3 paper, sort of moving the drawing around on the workspace so that I could print it in pieces, and then I've cut the pieces of paper and joined them together with sellotape. So that's the wing section. It's quite a thin wing, and it's quite frightening as to how we're going to do that, but anyway, keep that in the back of your mind. That's a problem we need to look at. The bulkheads for the fuselage are very simple, and we've got 3 sections to work from, and as you can see, it's a triangle with a semicircle at the top. The leading bulkhead is a bit more than a semicircle. It's raised up a little bit, but it's still basically a semicircle. So this is all really fairly straightforward stuff. So if we look at, let's move them over there a little bit. The plan form is fairly straightforward. It has a section that is a bit deeper than the root rib. So I'd call this the root and this the root rib, I guess. But it's fairly straightforward. I'll try and replicate the number of ribs. The crucial bit that we'll come to in a little while is that this model is going to use wing warping. So that's going to be a bit exciting. So the way it works, it has 2 spars, and the forward spar is also a pivot, and the rear spar lifts and lowers, i.e. the whole trailing edge of the wing goes up and down through wing warping. And what we have is 3 wires that go from the rear spar. They join together, and then they go to a pulley on the top of a post, and on that post they then go down to the cockpit and are pulled up and down. The wires that go to the main spar, the leading spar, are fixed to the post as well, but these 3 wires are fixed, and they hold the wing steady and true and everything else. So that's what we're going to attempt. So that's the plan view, and all I'm going to do is probably build a laminated tip and probably some carbon tube spars, something like that, to make the outline and the ribs. I'm not sure how I'm going to do those yet, but they're probably going to be balsa, and they're probably going to be solid balsa. I would normally do a lamination of top and bottom and just curve it, but I think in this case, because the wing is so thin, I think I'm going to use probably balsa. So the front view, fairly straightforward, it's fairly normal. You can see the three lines that go up. What you're actually seeing is 1, 2, 3, 4, 5, 6. It's because it's the three leading ones and the three rear ones. And that is mirrored on the bottom. The three leading ones that don't move are fixed to the front skid, and the three that pull up and down with the three that pull up and down from the trailing edge at the top go through the skid behind the wheel, and then they go up on these wires up into the cockpit, so that the whole thing is a loop. So as you move that loop, the wings warp, and that's what we're going to try and replicate. That could be a challenge. Then we come to the two interesting views. Well, not that the others aren't interesting, but the two probably more interesting views. This is the side view and the top view. So on the side view, you can see we've got a skid, undercarriage, engine at the front, and a triangular section side view. Now you can't build the side view on that because this is angled like that. So if you built the side view to that outline in that dimension and in that plane, when you lifted it like that, it would be the wrong shape. So you're going to have to be a little bit more cunning as to how we build it. So what I'm going to do is I'm going to build this as a outline in balsa, completely like that. And then from the top view, I'm going to build this as an outline, again in balsa. And then I'm going to position that flat plan view on top of that flat side view, profile view. And then I'm going to build these bracing things from the bottom to the side of the top bit. You'll see. So I'll build it in situ so that underneath all the outer skin there will actually be a T, which will be the top of the fuselage and a spine running down the fuselage, and that should give us the strength. The Blackburn has a very interesting feature in that the fabric work is done in a very strange way. One side, and if we take the fin and rudder, for example, the starboard side of the fin and rudder is fabricked with one piece of fabric, and then it's wrapped round the perimeter. And then on the port side, the area and the sections have tapes over the pipework or over the tubing, and that's what you're seeing outlined in this drawing, is the actual fabric tape. So in the center section of the fin, for example, there is only one thickness of fabric. Quite clever. And if you go to the tailplane, it is also done in that same way. So on top is one piece of fabric, well, one piece for the tailplane and one piece for the elevator, and it's wrapped around the tube. But then on the underside, only the outline is taped, so that the center area is only one piece of fabric thick. So that's something we've also got to try and replicate. So there we go. That's what we're going to do. We're going to try and build a 40-inch RC model of the Blackburn 1912 monoplane to compete in the open scale at the 2025 Indoor RC Scale Nationals. So for power, I'm going to use this 2200 kVA brushless motor. It's quite light, and then I've got an ESC, a 6 amp brushless ESC with a built-in BEC, and this will provide 6 amps of current for the motor, which should be more than enough. And it's a 2 to 4S unit, so I'll probably be flying this on 2S because it's a lot easier to find 2S batteries than it is 1S at the moment. Anyway, So there we go. That's the next little project. We'll get back to the chipmunk when I feel like it, but the beauty of aero modelling is that you just flip between one thing and another, so that's what I'm doing here. As you can see over my shoulder there, the pilot is all done and his head is painted. That's for the tiger moth project, and the head is now glued on and he's just drying, the epoxy is drying. So once he's sorted, I'll get him in the cockpit and we'll get him strapped in, and then we're just waiting for some nice weather so that we can go and give the tiger moth a bit of an airing and see how well that flies. But in the meantime, we'll get on with outlining these the fuselage parts, because this is going to be the trickiest part of this model. So I think I'll start there. So if you want to follow along, click subscribe and you'll get notified of whenever a new video comes out. And we'll see what we can do with this thing, see if we can make it work, see if we can make it fly, see if we can make this wind warping work, for God's sake. That's got to be a challenge in itself. All right then, see you on the next one.